On the 26th of April, 1986, Reactor 4 at Chernobyl nuclear power plant exploded, catching the whole world off guard. For the first time in history, massive quantities of radioactive particles were spewing out of the core of a nuclear reactor. A veritable war had to be waged to contain the deadly emissions. But 10 years later, an extra 15 billion becquerels of radioactivity were spread all over Europe. Over 80% of the elements in the fallout from the explosion had a short half-life. However, one of them, iodine-131, caused an epidemic of thyroid cancers among children. 30 years on, it continues to claim lives. The other 20% will affect the environment for centuries to come. Some will be radioactive for tens of thousands of years. For mankind and the planet, the long-term consequences of this disaster were a plunge into the unknown. From then on, millions of people would be living on land contaminated by radioactive pollution. On March 2011, the accident at the Fukushima power plant reminded us of the constant risk. There was only 1/10 as much fallout as at Chernobyl. But another region was polluted, and other men and women were abruptly faced with the prospect of life on contaminated land. Nuclear accidents change our world for eons. But 30 years after Chernobyl and 5 years after Fukushima, what do we know about the consequences of living with this contamination?
One day, it came. The radioactivity from Chernobyl rolled in. The explosion, the misfortune. They said the wind brought it. It flooded us like a wave. I don't know exactly how, but that's what happened.
The fallout from Chernobyl mapped out a type of territory quite new to human history. Huge areas characterized by their degree of radioactive contamination. The most fallout had settled around the plant. A 30-kilometer radius was marked out, where the radioactivity exceeded 40 curies per square kilometer. It was declared the exclusion zone, too poisonous to inhabit. It became known as the zone, and in the collective imagination, it now represents the ultimate consequence of a nuclear accident. Land from which man has excluded himself for an eternity. 250,000 people who lived in the area have been evacuated from their homes, never to return. 2 cities and hundreds of villages were abandoned, empty shells. But just outside this forbidden zone, a somewhat different story begins. Here, cesium-137 levels were lower than 40 curies per square kilometer, but still over 1 curie per square kilometer, considered to be a normal amount of background radiation. This radically new kind of territory covered over 120,000 square kilometers. After the fall of the Soviet Union, it was under the jurisdiction of 3 countries: Russia, Ukraine, and Belarus, the last of which inherited 70% of the fallout. Nobody was evacuated from these contaminated territories, as they would henceforth be called. Life was officially considered to be possible there, as long as certain precautions were taken. The inhabitants were free to stay in the area or leave. They could sign up for rehousing. Living in this zone exposes the inhabitants to doses of radioactivity officially classified as low. But the exact health consequences for them and their children due to these low levels of radioactivity is still beyond the limits of scientific knowledge. Since 1928, the International Commission on Radiological Protection has been setting world standards for exposure to radiation.
Above something like 100 millisievert, it's clear that radiation causes cancer, increases the chance of getting cancer. But at lower doses, it's not so clear. The best I can say is that at these very low doses, we've never seen effects in the population using epidemiological studies. But there is at least a theoretical risk of very small effects at these very low doses.
In fact, like everything in the post-Chernobyl world, life in these areas is a big, open-air science experiment. And it is not limited to the regions adjacent to the plant. At the time of the disaster, the winds carried radioactive particles over thousands of kilometers. They fell to the ground mainly with rain, creating contamination hotspots. In 1986, Norway, which has no nuclear power plants, was the Western European country that received the most fallout. Particularly affected were the sparsely populated mountainous areas in the center of the country, traditionally used by the indigenous southern Sami people as grazing land for their herds of reindeer. They too would now have to live with the consequences of the pollution. In the aftermath of the explosion, a total of nearly 7 million people found themselves in the gray zones created by Chernobyl. The sheer numbers of people concerned make the ordeal of living with contamination the biggest consequence of the catastrophe. Yet we quickly lost track of the fate of these men and women. Other priorities took precedence. In March 2011, the accident at Fukushima Power Plant 1 created a new exclusion zone, this time in the heart of Japan, one of the world's great economic powers. Authorities applied the same radiation limits as at Chernobyl, and 170,000 people were evacuated. And once again, tens of thousands of people suddenly discovered they were living on contaminated land. And their future is outstanding. Most of them want to stay where they belong, but no one really fully understands the degree of gravity of the situation. The village of Suetsugi is located less than 30 kilometers south of the plant, but radiation levels are lower than 40 curies per square kilometer. It is therefore classified as a low-level contaminated zone. 1 year after the accident, the inhabitants still couldn't understand why no one considered evacuating them. How are safe limits defined? What risk are they being made to run?
1ミリだから安全だってことじゃないんですよ。放射能に汚染されて、その放射能と共存したくないんですよ。だから東電は全部ね、放射能持ってけっていうふうに思ってるんですよ。
でこの辺の値でどのぐらいの作物とかね、作っているのか。最終的な石炭アメリカはね。
Should they leave everything behind? Or should they stay and live with an invisible threat said to be slight? Vital questions arise. Can they really live here? What are the risks? How can they protect themselves and their loved ones? If they stay, what are their prospects for the future? And in answer to these simple questions, they obtain no clear response, just a pile of contradictory opinions and an avalanche of mysterious figures. Amid this confusion, an idea emerged. The Japanese might get some solid answers from people with 30 years of experience of life in the Chernobyl control zone, the only place on Earth similar to theirs. By 2012, various NGOs had managed to establish links between Japan, Belarus, and Norway. The Japanese were surprised by what they heard.
In Belarus and in Norway, I was told the same thing. Learn the lessons from our experiences. It really surprised me. I was happily surprised to know that they were really concerned about us and that they felt true sympathy for us.
They were afraid of breathing in contaminated air. They were afraid of eating the food. One woman said to me, "I'm even afraid to drink the water." Initially, just after the accident, we were afraid of everything too. It took years for the authorities to set up measures to deal with the problem. In later years, they were implemented. Of course, at first we were afraid. It's frightening. The people of Fukushima were interested in what we had done and how we had done it. I told them, "You're lucky, you can learn from our mistakes." But we were the pioneers.
The tale they told the Japanese was that of a complex, disturbing path. It was their own personal story, and they were aware the story would not be the same for all the people who had remained. But it was also for that reason they felt the need to share it.
If when it happened, there had been people like us to support us and tell us, "Calm down, don't give way to panic despite the situation." Or, "Eat this, don't eat that." I don't know. Just giving recommendations for everyday living. That would have minimized what happened. At the time, we didn't have that support. The information was not yet available. If we'd had that information, we could have avoided a lot of mistakes, and there wouldn't have been so much suffering.
Olmani is a Belarusian village with a population of about 1,000. It was among the most heavily contaminated in the district of Stolin by the Ukrainian border. Pasha and Vladimir Polakoshko volunteered to discuss the terrible post-Chernobyl years with the Japanese.
Вот снова беда, Чернобыль взорвался, черные тучи над деревней легли, но люди не дрогнули, люди остались, покинуть свой дом они не смогли, но люди не дрогнули, люди остались, покинуть свой дом они не смогли.
Of course, in the first few years after the accident, there was anxiety. Anxiety about the future, anxiety about the children, and about what lay ahead of us. Uncertainty. There were no safe tomorrows. Everything was unclear.
Although the Samis of southern Norway faced less contamination, they spoke of the same despair, the same uncertainty, and of the anxiety it aroused.
The insecurity and the uncertainty had the biggest impact. All the bases of our traditions, culture, and security, everything our future held, collapsed. At the time, it was difficult to know what was going to happen.
People everywhere were struck by their powerlessness to overcome this baffling, invisible threat, like an inescapable doom.
I have 4 children alive today. One died, I don't know why. They said it was because of the radiation. It was his destiny.
People, especially the elderly, didn't believe, they didn't understand, and they didn't trust what they were being told. What could happen to them? But time revealed that there were more cancers. My mother died from cancer, and my sister's husband died from cancer, as did many neighbors.
But they were eager to communicate with the Japanese victims because dealing with decades of anxiety has produced some essential wisdom.
Life got back to normal when we were able to obtain the information we now possess. When we understood that we didn't need to be as frightened as all that. When we understood that life had to go on for us, but we needed to be aware where we were living.
10 years after the catastrophe, as a part of the EU Ethos program, a French team came to Almaty to help the local people. They were struck by the hopelessness of the people and how much it was caused by the lack of information about their situation.
Actually, the Almanians had no idea of the radiation levels. No one came to fetch their milk anymore, and they interpreted that as a sign that the situation was bad. And the question that kept coming up was, can we stay here? Can we still live here?
The Ethos team tried to teach the inhabitants how to understand the pollution in their surroundings so that they could make informed decisions about what to do.
When the French arrived, a new life began in the village. There were a lot of projects covering various topics, and a lot of people got involved. We took an interest in things, and change started to come about. It was gradual, though, not all of a sudden.
The first thing the French brought was instruments to measure the radioactivity. They were not the first to do so, but they were the first to hand over the devices to the locals themselves and to discuss the results with them. For the inhabitants of Almaty, it was a revelation. They were discovering the real face of the environment they'd been living with for 10 years already.
And so little by little we started to see a new image of the village emerging. Levels varied drastically. There was no mean value. For example, background radiation in one person's yard might be the same as in Paris. Right next door, the radiation levels could be 5 or 10 times higher. All of us were pleasantly surprised to find that indoors, radiation levels were normal.
Even on the scale of a village, radioactive particles are not evenly scattered. There can be enormous gaps between sites that are very close to each other. Background levels were still rather high in certain gardens and above all in the forest. But thanks to the measurements, the radioactivity ceased to be an invisible, omnipresent threat. In 2011 in Fukushima, the inhabitants were able to obtain the necessary instruments more rapidly. Again, access to knowledge provided great relief. In Suetsugi, Mr. Endo started carrying out hundreds of measurements all over the village. His findings enabled him to draw up a detailed map of the contamination, a map on a scale that was much easier for the locals to read than the official reports.
Actually, by carrying out the measurements and mapping the hot spots, I was able to see the ghosts' footprints. The map became a way to find out where the fearsome ghosts were hiding, and whether they were weak ghosts, powerful enemies, or enemies that are hard to fight.
In the so-called lightly contaminated zones, it is the accumulation of doses received over the years that presents a potential threat to health. Avoiding the most contaminated areas or limiting the time spent there significantly reduces the theoretical risk involved. In the first few years after a nuclear accident, the contamination evolves. Particles can be moved by wind and especially by rain. Levels of ambient radiation drop in some places and rise in others, hot spots where particles have collected. In order to obtain a clear reading of the new environment, ongoing measurements are necessary. They alone provide the data needed to deal properly with the threat.
We take measurements every day. When the parents saw that radiation levels were dropping, they were willing for us to let the children play outside for longer.
5 years after the accident, in the cities that received low levels of fallout, like Fukushima City, the background radiation is again equivalent to that in Paris. In urban environments, the particles do not penetrate the soil and are eliminated more rapidly, partly due to daily cleaning. Gomel is the second largest city in Belarus. In 1986, it was one of the most contaminated zones in the country. Today, it has a population of over 500,000. 30 years after the accident, ambient radiation levels are normal, as they are in nearly all Belarusian villages. Most of the remaining hotspots are in the surrounding forests. However, the villagers are aware of the new parameters and consider them as the new norm.
I have lived here for 30 years, ever since I was born. I was born in 1985 in Cameron and grew up here. We know exactly where in the forest we can go, and we know where we can go in the river. That's why we're not bothered by the radioactivity, in the sense that we wouldn't go there. The closed-off zones are closed off. We just don't go there, that's all. There are barriers and information panels. There aren't any problems with the other places.
But massive contamination of the environment is not limited to ambient radiation. Gradually, the leaves and grasses absorb the radioactive particles. They accumulate in the humus, seep into the earth, and are taken up by the roots of plants and trees. They are then ingested by the animals that feed on the plants. The biggest long-term problem that locals face is lasting contamination of the entire food chain. A phenomenon that was largely underestimated by the scientists, who only discovered the extent of the issue in the decades after Chernobyl. Grain, vegetables, meat, milk, all products are affected to varying degrees and could become sources of exposure for those who eat them. The areas polluted by fallout from Fukushima and Chernobyl are mainly farming regions. The town of Date is located about 60 kilometers to the north of the Fukushima power plant. Its surroundings have a reputation for the quality and richness of their orchards. The accident happened in March. A few months later, the harvest season began.
It started with small plums, then larger plums and peaches. We discovered radioactive cesium in all the summer fruit. Then we also discovered it in the persimmons. There's a young tree over there. The first year, we dug out a big hole there with a machine and threw all persimmons into it. When that filled up, we left the rest in the corner of the orchard. That went on for 2 years. I was terribly affected by it. It made me want to cry.
In Belarus, Europe's third biggest milk producer, 20% of the country's farmland was polluted by fallout from Chernobyl. Finding a way to maintain the economic activity of those areas was therefore a priority for the state.
The scientists knew very little about how these radionuclides spread through nature and how they penetrated plants. In 1991, a major scientific program was launched. It included the development of countermeasures, measures to protect agriculture, and the management of farm produce, so that the end products would contain minimal rates of radionuclides.
The Institute of Radiology, created just after the disaster, was one of the spearheads of the farming rehabilitation program, to which Belarus devoted nearly 1/5 of its budget. Over the last 30 years, scientists there have carried out ongoing tests of the region's soils and farm produce, and they have gradually put together a whole battery of technical solutions in order to adapt production to soil contamination. In Belarus, agricultural production is organized in kolgozes or collective farms. Tamara Kudan runs a collective of 3,800 plots of farmland in the district of Brain.
The Gomel Institute of Radiology developed maps of cesium and strontium contamination in the region. The main task of our experts, as well as mine, is to carefully position the crops in relation to the contaminated land. We also use phosphorus, which we add in the spring, and we also use nitrogen fertilizers.
All these discoveries are the result of pioneering research in various fields, carried out to solve problems that nobody ever had to deal with before. They required a great deal of back-and-forth exchanges between theoretical research and experience in the field, and it took around a decade for this work to bear fruit.
Around 1994, on major farms in the state sector, large cooperatives and state farms, we succeeded in getting all the produce to conform to norms.
In Date, unions of small farmers are cooperating in a gigantic undertaking, decontaminating their orchards according to the scientists' recommendations.
We have decontaminated the barks of all the persimmon trees. We spray them with high-pressure hoses.
Decontamination using high-pressure water took a total of 4 months. 35,000 people have been involved.
We decontaminated a total of 550,000 fruit trees, including 250,000 persimmon trees. We worked until March 2012.
4 years later, production is showing signs of picking up again. But the cooperative has had to invest a large amount of money in a high-tech lab to test the produce and guarantee its safety. Relaunching a region's farming economy, even on a lightly contaminated land, can be done, but it requires an effort on a scale comparable to post-war reconstruction. In Belarus, unfortunately, it was discovered that even this was still far from sufficient. Due to isolation, in remote rural villages, people had always subsisted, and still subsist today, on produce from their own vegetable gardens, on the milk from their cows, and on berries and mushrooms gathered in the forest. 5 years after the accident, 400 radiation safety centers were established in the affected areas in order to measure the contamination of local food produce. Pasha Polukoshko volunteered at the center in Almani.
During the tests, I gave them the produce. They put it in the device, and the radioactivity was off scale. The meter went from 18 to 37,000 becquerels, and we exceeded 37,000 becquerels.
In fact, since the accident, practically all the produce locals were consuming on a daily basis was contaminated, some of it very heavily.
When we first got here, everything had been outlawed. Gathering mushrooms and berries, drinking the milk. It was forbidden to go into the forest, etc. That just didn't make sense for the people living here. So, in reality, everybody went into the forest and everybody gathered mushrooms. And everyone was living with the same idea, more or less. Well, here we are, surrounded by pollution, we ingest it every day. In the end, it'll ruin our health and the health of our children, but we have no choice.
But the measurements revealed a surprising phenomenon. Within the same forest or the same village, some food was highly contaminated, while other food was hardly contaminated at all. At the time, locals were totally unaware of the situation. 10 years after the accident, when the first tests were finally carried out to measure contamination within the population itself, the consequence of this discovery came to light. The whole body gamma ray counts of children from the same village varied widely. Food was the main culprit.
With the help of the local mothers, we examined children's daily quotas, then carried out calculations. We wondered what the result would be if the family was lucky enough to consume the least contaminated products in Albany. That figure was somewhere between 30 and 50 becquerels ingested on a daily basis. Then we looked at figures in the unfortunate case of a family eating the most contaminated products in the village. In other words, the same diet, but with the most contaminated products. That figure was somewhere between 700 and 800 becquerels ingested a day. So that makes a huge difference.
The contamination of the food chain caused the Sami people another major problem, in addition to the problem of livelihood. These animals do not fare well in captivity. They need vast areas of land where they can forage freely all year round. In winter, they mainly feed off lichen, and they're also very fond of mushrooms. But lichens and mushrooms have the terrible property of concentrating radioactivity.
The first season after Chernobyl, all the reindeer meat in the region had high becquerel counts. So that first year, all the meat was declared unfit for consumption. Of course, it was sad to see good reindeer meat being buried or treated as toxic waste. But we had received promises that we would get help.
From the first year, campaigns to test the meat and systematic financial compensation for the farmers were implemented to avoid economic disaster for the Sami people.
The first year after Chernobyl, we were able to obtain meat from other regions. But traditionally, we ate the entire animal. The offal, the blood, the marrow, and the head. These products were difficult to obtain from elsewhere, so we couldn't perpetuate the tradition.
I started to fish less, because the fish had high levels of contamination. We gathered fewer berries and fewer edible wild plants, such as sorrel, alpine saw thistle, and angelica.
Sami culture is based on a balanced exchange with the environment and on total use of the animals they slaughter. This way of life, in harmony with nature, is the core of Sami identity, passed down through the generations. To give it up to avoid radiation poisoning was a painful psychological sacrifice. Lavrans Skuterud works for the Norwegian Radiation Protection Authority. In 1996, during a measurement campaign, he realized that due to a lack of meaningful exchange with the Sami people, the severity of the consequences of this situation had gone entirely unnoticed.
I had worked for several years on a project in Russia, Ukraine, and Belarus, carrying out measurements on people and studying their diet. I didn't expect to find in the Sami population of central Norway levels that were as high as in the most contaminated populations around Chernobyl.
In Almaty, whenever a child showed abnormally high gamma ray counts, members of the Ethos program visited the home to enlist the family's help in identifying the foods or behaviors responsible. Because contamination of our bodies is not irreversible. Once we stop eating radioactive particles, our bodies can eliminate the buildup naturally, and levels gradually fall.
Within a year, we brought down the levels in children who had very high levels to among the least contaminated levels in the village. Because suddenly the family had the ability to monitor and regulate the daily intake.
This approach was so successful, it was extended to 4 other contaminated districts of Belarus under the core program in the beginning of the 2000s. Although the situation was not an easy one, the people of Almaty were gradually regaining control.
Команда французов по программе Коре, а тоже в Альманы на помощь пришла. Они услышали наше горе, учили, что без радиации картошка росла.
They now knew it was possible to fight contamination by experimenting with various new behaviors and adopting those that would achieve results.
We had the milk tested and stopped consuming our own. We bought milk from the shop. We tested the produce we grew in our vegetable patches too. If it was contaminated, we stopped planting it. Following the French recommendations, we tried to grow our own cucumbers, cabbages, and tomatoes. They were all clean and we could sell them.
We began to learn. There were ways of reducing the contamination. I carried out my own experiments. I picked mushrooms from various places, salted them, and threw away the brine. Half the radiation comes out in the brine. Then I'd make up a new brine. I was happy with the results and I showed them to people. It's true that the mushrooms weren't quite as good as before, but I managed to obtain results that were within the norm.
Detailed knowledge began to emerge, resulting from a combination of advice from experts and self-made local discoveries. New behaviors were integrated into daily life, forming a new culture.
Instead of a top-down approach, where authorities were dictating what people should do, there was a grassroots movement. People talked among themselves, made decisions, and started acting on them because they owned those decisions. Instead of being helpless victims, people became motivated individuals, certain that they would lead better lives as each day went by.
In Norway, as a result of closer dialogue between experts and reindeer herders, appropriate countermeasures were gradually adopted.
The main measure was to provide herds with special fodder that brought their contamination levels back down under the limit at the time of slaughter. We had to build feedlots for the reindeer because we slaughter several thousand head over the course of a year.
When the reindeer are corralled and fed clean lichen for a few weeks, their bodies naturally eliminated a large percentage of the radioactivity. Levels of contamination fell rapidly.
We had to import large quantities of reindeer lichen for the clean feeding phase. We had to change the annual reindeer slaughter to early autumn. We have kept it that way.
All of these adaptations involved a great deal more work for the Sami herders, but they have proved to be effective. 30 years after the accident, the most recent measurements carried out before slaughter are encouraging, even if great variations still occur from year to year.
We've never measured levels as low as the ones we have today. We have learned that the highly radioactive mushrooms the reindeer eat are the culprit. This year, there are very few mushrooms, and we were expecting the animals to be fairly clean.
Today in Belarus, the teachings of the Ethos and Core programs have been integrated into the functioning of the medical systems in the control zone.
Today, in the affected areas, there are 16 radiological control stations, including our laboratory. Any locals wishing to do so can contact any of the centers to test their food produce. They can also test food from the forest, like mushrooms and berries.
Whole body counting has become a quick, simple medical exam. It is free, and people can drop in at the district hospital without an appointment.
All the patients we hospitalize are systematically tested. On our machines, we carry out over 8,000 tests a year, about 2,000 children, and the rest are adults.
These tests play a key role. They relieve anxiety, and more importantly, they detect spikes in gamma-ray levels that can then be dealt with. Tatiana Kotlabai is a nurse and dosimetrist at the Cameroon Test Center. She does post-exam follow-up with families, helping them understand the results. If necessary, she suggests changes in dietary habits.
For several years now, we no longer have contaminated milk or contaminated cultivated produce. The risks are mainly linked to wild foods, berries, game, of course, and fish from the closed-off basins. We always discuss these risks with people. Our recommendations are simple. If you go game hunting and pick berries and mushrooms, you must have everything tested. Or you just don't hunt, don't gather, and don't eat any of these products.
This tailor-made approach has since proved to be effective.
I remember years when there were over 200 school children in Almaty with high radiation levels. But over the last 3 years, we haven't detected a single person with a level above 1 millisievert a year. We're very happy about that.
Sami herders also judged that their way of life has returned to normal in the past several years.
We have gone back to eating our traditional, everyday diet of dishes, made of organ meats and blood, the way we did before Chernobyl. We pick mushrooms and we eat fish, and we have resumed our old ways. The only difference is we want to be tested every year to make sure that everything is okay. I also think no other community in the world knows as much as the southern Sami people about radioactivity and its effects.
And for the new generations, other problems have already replaced those of Chernobyl.
Today, we have tests for our own radioactivity. Vets also come to test the radioactivity levels in the reindeer. But we don't really think about it on a daily basis. It's not a problem. The situation our generation faces is totally different from the one our parents experienced. Our parents were mainly worried about the radioactivity, whereas the issues we're concerned with are predators and society in general, which is encroaching on our open range.
It has been up for 30 years now and seems unlikely to disappear soon.
I remember one event at primary school. We were being tested, and I had very high levels in terms of becquerels. The teachers told us our children might have birth defects.
Yes, people who come from outside are also the most skeptical. They give us their opinion and frighten us the most. Our parents and other people who have always lived here told us they were very frightened when they didn't have the necessary knowledge, but they have since gained that knowledge, and that's what they have passed on to us.
Today, the views of people living in Brahin and Stolin are much the same as those of the Samis in Norway.
It's been 30 years. Now we're living the way we did 30 years ago.
We're at peace now and balanced. We've gained life experience. Quite simply, we learned a whole lot about radioactivity. We learned how to manage it, so to speak.
And doubts about public health continue to loom in the control zone due to scientists' uncertainties about the effects of low-grade exposure.
The fact is that science has not been able to establish how harmful low doses of radiation are. Our own experience will help answer this question.
Here, as in Norway, people observe the same phenomenon. One of the most difficult things to live with is the judgment of people from outside the area.
I think that either people don't want to understand our lives, or quite simply, they're not interested. Today, we also want to develop economically. I wish they'd understand that for us, Chernobyl is something distant, that we are inhabitants of Belarus just like everybody else. If only we could get past the Chernobyl, not Chernobyl divide, I think our problems would be solved, and the region would develop.
Today in Belarus, efforts are aimed at disseminating the knowledge acquired in these pilot districts. 30 years after the disaster, people in other regions, and probably in Ukraine and Russia, are underinformed and anxious, lacking the peace of mind of those in Almani and Kamarin. Education is the key. From an early age, children are now taught the reality of the conditions for a sustainable life in the control zone. And it is because the Samis and the people of Belarus know the importance of peer-to-peer transmission that they eagerly took part in the Fukushima dialogues. 12 of these encounters, under ICRP auspices, were held in the province of Fukushima between November 2011 and November 2015. They were an opportunity for Japanese people to converse with people living in contaminated areas elsewhere and with experts. Besides providing practical and technical information, these encounters enabled victims to compare experiences, bringing certain unsuspected consequences of the contamination to light.
We've learned a lot about recovery in Fukushima, different than was learned from Chernobyl. A big lesson is that even in an accident where there doesn't appear to be any health effects from exposure to radiation, there are still enormous consequences, social, economic consequences from the accident.
The human dimension of a nuclear disaster is enormous. And I think it was not taken sufficiently into account. Even after Chernobyl, it was brushed aside. We are so deeply focused on public health aspects and measures that we tend to be blind to the impact on society.
Since Chernobyl, we have all been petrified by the very idea of radioactive contamination. And yet we continue to build and operate nuclear power plants.
In this world, nobody is immune. Nobody can say they are protected and that it would never happen again. People must acquire the necessary information so that if one day such a disaster were to happen again, they are prepared. And they know who to turn to for help and where they can access knowledge.
The question is not if there will be another accident, but when. That's the feeling we're left with. But the next time, we'll already know a lot more.
What these people reveal about the full meaning of living with contamination confronts us with an even bigger issue. Other industries, other technologies are leaving a pollution footprint on our planet. The gray zones are growing. Are our comfort and convenience really worth adapting our lives to a poisoned environment with all of the constraints involved?